All right. Welcome to Exclusive Tutoring's Calculus AB review for the AP test. What I want to go over here is our first segment. We're going to talk about the mainframe, the framework that they use in order to set up this test. You may have already gone through your Calc AB course, but what I want to do is break it down into the segments that not only makes sense to me, but makes sense in terms of how you should be approaching that AP test. Because at the end of the day, they're looking for very specific things. And if you can understand how the test is set up and what the different segments of Calculus A and Calculus B are, I think it's a lot easier for you to understand what to expect when you come across the test. Of course, we will also later on go through the free response questions, the FRQs that are from 2025, 2024, 2023, the ones that are still currently available up on the AP website. Keep in mind too, the AP test is actually designed in a way where you not only need to be able to explain or at least set up the problem, but also solve for it. I will say that a very large majority of students that I end up teaching, a part of it does come down to making sure that your algebra is correct. You can still score pretty well and still be able to pass the AP test with at least a 3. But you have to make sure that if you miss the algebraic questions, if you have a missing segment, a missing, dx or a plus c in your integral, little things like that can actually take away from the extra points that would get you to the 4 and the 5. What I want to go over here is just the way I've set it up here. Level one are our definitions. On the left side here, we have derivatives, which is what I consider calculus A. On the right side is calculus B, which would be your integrals. All right. So to start off, obviously, we have to understand our fundamental theorem of calculus. That ultimately is just your equation. This may look a little bit different depending on your teacher, depending on the book you use. Sometimes they use delta x, but the limit as h approaches 0 of this slope function, where you do have f of x plus h minus f of x all over h, right? Limiting h to 0. Most of the time as well, you very rarely have to actually rewrite this whole equation. We very quickly jump into our rules, our power rules, our product rules, quotient rule, chain rule, and being able to do our trigonometric derivatives and the inverses as well. But from our fundamental theorem of calculus, obviously we need to understand how limits and continuity work because we cannot take derivatives unless something is continuous and without any cusp points as well. From there, there are three main rules or three main theorems that you are expected to know. Your mean value theorem, Rolle's theorem, and your intermediate value theorem. You should be able to explain these to anybody very quickly. Mean value theorem is the average value. So when you go from point A to point B, there must exist that average value at some point in the middle of that graph. Rolle's theorem is where you think about it in terms of there is a 0 that exists in the middle. And the very last one, intermediate value theorem, basically means that there has to be a value in between those 2 points that you're given. All right. Obviously, these are theorems that you do need to be able to explain. We will have a segment that goes over them more in detail later on. L'Hopital's rule. Basically, if either of the top or especially the bottom of your fraction limits to 0, you should be able to find the derivative of both the top and the bottom and use that to evaluate a where something is going to go. Okay, and squeeze theorem as well, using these in terms of the theorems to describe and to be able to identify potential points on a equation that is given to you. From there, you got to understand there's basically three main things that come out of your applications when it comes down to your derivatives. Implicit differentiation is just being able to derive anything when you are given the y and the x, or basically two variables on each side. Related rates, in this situation, I would even say you should be able to understand how to find the approximations of a function. And that's very easily, you usually can find that if you see it, asking you to estimate for something with decimal points. So, f of 3.001 or f of 2.999, using your derivative to set up a line equation and using that tangent line to help you estimate where something's going to go. Optimization, making sure that you understand your first and your second derivatives and how that relates into maximum minimums, concavity, and where a point of inflection may be. All right, so your first derivative helps you find, setting your first derivative to zero helps you find your critical points. Your second derivative can help you find concavity, or you can still use your first derivative and plug in points around those critical points in order to determine what is happening with concavity. And what a point of inflection means is where concavity meets on the graph. All right. In terms of your integrals, we got to understand how to set up Riemann sums, the area under the curve in terms of a actual definite integral and the equation for an indefinite integral. This also brings into a very specific point. The test is generally set up with three main types of data delivered. Okay, so what that means is the first thing you can expect is that they'll give you a function. All right, so that's the polynomial, right? Whether it can be exponential, can be logarithmic, things like that. But they can give you the data in a function. They can give it to you in a graph. Okay. So in this situation, it's a visual graph. For example, I could show you here on, you know, any of these could be the graph that you're being asked to use in order to define something. And then the last one that they could give you would just be a chart. Okay. So they can give you the data in a uh, data table chart. And that is, that very, very often is going to be used in order for you to help, determine either mean value theorem, Rolle's intermediate value theorem, or as well, Riemann sums are very common with that as well. So you got to be able to explain not only derivatives, but also integrals regardless of which of these three situations they give you. You can expect in any test that they'll give you a function, a graph, and at least a data table or that chart. And then they will all obviously alternate through them, but expect at least one of each in your free response questions. Then from there, you can understand that they will ask you for it's either going to be your function, your first derivative, or your second derivative, right? You should be able to not only find each of them, but also be able to go backwards and find your integrals and understand how you're using them to describe your data that's being delivered. Okay. In your integrals, you also have area between two curves, U substitution, and trigonometric identities. I do find that trigonometric identities start to be, they're fairly rare nowadays in the AP test, but do be, be prepared for them if they do show up. The tougher things that in your applications, you will be asked to do cross sections, being able to find the volume of area under the curve and the rotations as well. Okay, so whether they create cross sections with that area under the curve or they create volume, so a three-dimensional rotation around an axis or around a specific line. Be ready for all of that as well. All right. Let me real quick, we're not actually going to do the problems just yet. I'm going to save that for a different part of the a part of this series. But I do want to go through, we're just going to go take a quick look over here at the AP test for 2025 and kind of get an idea of what that setup really is, okay? So for example, here we'll read this out. Invasive species, a plant appears in a fruit grove at time t equals 0, begins to spread. The function c is defined by this function. Models number of acres in the fruit grove affected by the species t weeks after the species appears. It can be shown that the derivative of that, or the rate of change, happens to be this. So what you can see real quick here is they've given you the function and they've given you the derivative. Okay. And also, they've given it to you in a polynomial slash, in this situation, a trigonometric function to use. Okay. What are they asking? First thing, find the average number of acres affected by the invasive species from time 0 to time t equals 4. Show your setup for your calculations. So in this situation, that's basically mean value theorem when you think about it, right? So you're going to have to be able to find the average number of acres affected in this situation between those two times. So you can set it up as your f of you technically have two different ways, but in this one, if you set your integral of c of t from 0 to 4, and then you also have the, ignore that f right there, 1 over 4 minus 0. And here's a key too. If you forget that dt at the end, they're going to take away a point. So you actually have to write this out as your function and then obviously go through and solve. In this situation, you got lucky. You do get to use a calculator and they actually remind you to put it in radian mode as well. Okay. Next, okay. Each of these you have to make sure that you got 1 point for the actual function, you got another point for the actual answer. We'll go through that in the other segment. But just so you see, in these situations, you're given the function, you're given the derivative. You have to understand how to set things up. This next one asks you for average rate of change over that time interval, right? And so that's going to be your C of 4 minus C of 0 over 4 minus 0 in this situation. Pretty basic functions to understand, but you have to make sure that you write those out to get a point. Show your work. I'm sure your teachers have asked you to do that, but show your work before you answer. And in these first couple problems, you get to use a calculator. Assume the invasive species continue to spread according to the given model for all times t is greater than 0. Write a limit expression that describes the end behavior of the rate of change in the number of acres affected by the species. Evaluate this limit expression. All right, so in this situation, you want your limit equation as t approaches infinity of c prime of t, right? Because in this situation, uh, it is the rate of change of number of acres affected by the species, and that way it is essentially being plugged into this. Okay. That's pretty obvious too, because we are approaching infinity on this. The bottom gets very large, so it approaches 0. For D, time equals 4 weeks after invasive species appears in the fruit grove. Measures are taken to counter the spread of the species. The function A defined by this function models a Number of acres affected by the species over the time interval 4 to 36. At what time does A attain its maximum value? Okay, so if we want maximum value, you can understand this is the function that we're given. So we want the derivative of that to equal 0 because that's going to be my critical point, right? Critical point or critical value. Setting that together, basically setting this equation equal or the derivative of this equation equal to 0 is actually where the first point comes from. Finding the first derivative, setting equal to 0, finding that t value, and then potentially testing it out to figure out that it is a maximum value and not a minimum is where you want to do that. Okay. So again, you got to be able to go through these pretty quickly, but this first one, giving you a function and just it's the derivatives, right? Derivatives and your theorems, your mean value theorem with the average rate of change and things like that, being able to do that quickly. Second one, right here, we are given a graph, okay? And it's going to be, you can already see they're asking you to deal with this in terms of the area under the curve. In terms of the area under the curve, you got to be able to set up the area, right? Set up the area of R, show your setup for the calculations. And I always like to draw my lines here so that I know that it's going to be a dx type of situation. 0 to 3 is what I'm setting it up as. Top function of g of x minus my lower function f of x dx. Remember, if you forget that dx, you're not going to get your point. This is actually the first point for this, and then the evaluation of it gets the rest of it. Region R is the base of a solid. Each x the cross section perpendicular to the x-axis is a rectangle with a height x and base in region R. So find the volume of that solid. That's pretty straightforward. Show the setup for your calculation. Pretty straightforward. Again, it's still our 0 to 3, but now we're adding our x as the height, and then we still have our g of x minus f of x dx. That's another point right there, right? So again, we're not evaluating them just right now. We're showing you how quickly you need to be able to set up these equations. The rest of it will either be plugging these into your calculator for these first few problems, and being able to move through that swiftly because again, this is a timed test, right? Right, but do not evaluate an integral expression for the volume of the solid generated when the region R is rotated around the horizontal line of y equals -2. So we're going to rotate around here, okay? Rotate around here. Now, that does create a little bit more of, a larger equation, but you should understand your volume for these should be pi with the same function here, g of x minus, and we're now gonna make sure that we have that as the outside and this as the outside, minus the -2 squared, this whole function squared, minus, I'm gonna write it down here, f of x minus that -2, that part squared as well, right? Because again, it is outside, which is your g of x, and then you have that extra space to that -2, so it needs to be added on into there. Same with the inside circle, part of the circle as well. What am I missing here? We got to make sure we have that dx in here as well. Okay. For D, shown that the derivative, okay, is this function, find the value of x for uh, 0, x is between 0 and 1, at which the line tangent to the graph f is parallel to the tangent line of the graph of G. All right. So here, f prime of x is equal to g prime of x, which now we have our derivative, right? And this is given to us, so we have to set that equation equal to each other. So we derive this quickly is equal to the 1 plus pi cosine pi x. And that's your setup, and then you can use your calculator to solve. Okay. Part B, this one now you do not get your calculator for, but I will point out here, like I said, you're given the data table now, all right? And a data table, just the first one, the first problem we had, it was the function, right? Second problem we had, it was a graph. And the third function or third problem that we have right now is a data table, okay? You will see this over, it doesn't have to be in this exact order. They can swap it, but that's what you need to be expecting when it comes down to these types of problems, okay? Let's do this one real quick. And hopefully that helps explain the setup to these problems a little bit for you. I can see already here you are approximating parts of these. So r prime of 1, very possibly you have to look at that. That's in the middle of this. So our approximation is going to be r2 minus r of 0 over the 2 minus 0. Okay? Very, very quick, very, very easy. There must be a value c between 0 and 10 that RC is equal to 155. If you take a look at that, yeah, in terms of intermediate value theorem, that's basically what we should be expecting in this situation, right? So R being differentiable implies that R is continuous, all right? And therefore, it has to be between those values. So R of 0, R of 0 is 90, right? Which is, and 155 is in between R of 10 and 0, which is 162. So 155 has to exist somewhere in between. That's intermediate value theorem explained. Trapezoidal sum with 3 subintervals indicated by the data in the table to approximate this value. Show the work that leads to your answer. That's pretty straightforward. Basically, we're going to be taking the different uh the you can basically look at it as 0 up at 90 to 100 trapezoidal sum 8 150 and then 10 162, right? So trapezoidal sum is going to be r of 0 plus r of 2, right? Divided by 2 because that's going to be the trapezoid of it. Multiply that by 2 minus 0, which is going to be the width. Add that to r of 2 plus r of 8 divided by 2 times 8 minus 2, which is the width right here. And then the last one, r of 8 plus r of 10 over 2, right? Because it's trapezoid again, 10 minus 8. Add those together, that's going to be your trapezoidal sum for this function. D. Teacher starts reading at time t equals 0 minutes, continues reading for the next 10 minutes. Rate at which the teacher reads is modeled by the function w, defined by this, where wt is measured in words per minute. Based on the model, how many words has the teacher read by the end of the 10 minutes? Show the work that leads to your answer. So that's just basically, right, area under the curve, 0 to 10 of wt dt, right? So you can set that up with this function and then evaluate. Now, keep in mind, right? Each of these problems or, section section one was 30 minutes. Okay. Section two gives you an hour. I've gone through not only our introduction, but also these three problems in less than 20 minutes. All right. So it just shows you how quickly you need to be able to go through this. Another graph for us to use, right? Number four. Same number five, a function. I would expect to see at least one exponential function at some point during your equation, and then one more function at the very end. You see dy dx, this very likely means you're going to have to do some sort of implicit differentiation there. Okay. I'm going to do a full review of this entire FRQ test 2025. We'll actually evaluate these equations as well. But this introduction was basically to show you the setup of these problems. Again, you get functions, you get the graphs, and then you get data tables. All right. You can also expect to see a lot of times these types of graphs as well. So you usually have a area under the curve type of graph, and then you also have one where you're going to have to explain, uh, you know, derivatives alongside these as well. Be careful. Do they give you the function of it? Do they give you the derivative graph? You have to be ready for those. We'll also do some review of these situations so you understand what to expect. But get ready for this test. I know in terms of this 2026 right now, getting ready for this upcoming test in a little over a month. If you have any questions, don't hesitate. You can always message me. Um, and we'll help you guys out, get you guys ready for this upcoming test. All right. I'll see you guys in the next one.